Welcome to qnawire.
In this problem, we are going to look at the plant that we had in the previous case, and is so we have, but now we're going to assume that we have an isentropic efficiency in the turbine here of 90%. So this is no longer a vertical line. We have a slope here because we have an increase in entropy as we go through the turbine. So a lot of the stuff here is the same. Um, the all of this stuff is basically the same. So this is all the same here, except now we have this, and we don't have any the entropy. I forgot to write some things in here. This would be 5, and this is 6. And again, some arrows kind of help understand this, what's going on here. All right, so let's see here. Again, so the pump, everything to this point is basically the same as far as the analysis goes. Now, but now we have the specific, we have the isentropic case. So the isentropic entropy at 6, and at the isentropic case, the entropy at 6 and at 5 is the same as at 4. So we can get the isentropic enthalpy at 5, the isentropic quality factor at 6, and the isentropic enthalpy at 6. And then using the turbine efficiency, we can then get the actual enthalpy at 5 and at 6. So that's really where the difference comes in. And now, again, the enthalpy at 7, we have everything is the same here. And likewise, everything is the same here. But now some of these things are different. Wait a minute, is this 7 we have saturated? Yeah, 7 is the same, right? 762, yeah. And 3 is the same. And so here we have now this energy conservation for the control volume around the closed feed water heater. We wind up with, let's see here, entropy at 2 is the same, at 3 is the same, at 5 it's different. So we're going to get a slightly different value here. So that winds up being about, Y winds up being about 24.1% that we're bleeding off. And before we had about 24.4%. So we're bleeding off a little less, actually. So then the work in the turbine, again, is the same, just the same equation, just different values for our enthalpies. And we get 668.5 kilojoules per kilogram as opposed to about 740.9. So quite a bit less work in the turbine we're getting out because of this loss. Heat transfer in actually winds up being the same because H3 and H4 is the same as in problem 48. The net work is different because the work in the turbine we got out of the turbine is different. The work we put in the pump is the same. So we get 665.5 kilojoules per kilogram. And so then the thermal efficiency is this divided by this, and now it comes out to be about 28.3% as opposed to 31.4%. So again, as I expected, this efficiency goes down because we have a less efficient turbine.